Two-way tables are a way of looking at data which has two categorical variables and seeing if they're associated with each other. Now, that seems a bit complicated, so you have to think about the context of where you might see these and what sort of research questions you're going to devise to use this categorical data and how to interpret it. Examples that you might see in general are in genetics, where you're doing gene association studies. So what you have is your genotype, and you have whether somebody has a genetic disease or if they don't. So you can see if there's a relationship between that particular genotype and the disease. Now, most genetic diseases are not definite diseases. They can occur with age or with various other triggering factors, but they have some genetic effect in them. The other time you're going to use this is in public health. For example, the relationship between smoking and lung cancer was shown using two-way tables. So a two-way table is where the rows and columns correspond to categorical variables. You're checking to see if there's an association. So if there is an association between the genotype and the disease, then the probability of having the disease will be different between the different genotypes. Therefore, the probability is not independent. It's dependent on the genotype. It's not completely assigned at random between the two different genotypes. So then we can calculate what are called conditional probabilities. But more about that later. Now, I've already collected data for a two-way table in the week 1 activities when I asked you about fingernails. So what I was actually asking about was the question, does gender affect the way people look at their fingernails? Now, if it does, what you'll see is a different proportion of individuals looking at their fingernails in a particular way based on the different genders. So let's have a look at the tabulated data. So here you've got women, 188 have them curled up, 67 have them stretched out. In total there's 255. There's way more women than men, or way more women than men have filled in the survey, which is a usual response sort of rate. Amongst the men, 48 have curled up, 12 have outstretched. Amongst non-binary it's 1-to-1. I prefer not to say there's only one individual, so it's 100% in curled up. So looking here, if how you look at your fingernails is dependent on your gender, you'd expect the proportions in each of the different rows to be different. So in the first row you've got 74% against 26%, in the next row you've got 80% against 20%, and in the next row you've got 50% against 50%. So obviously 50% against 50% is very different to the others, but that's a very small sample. You've only got 2 individuals in that group. And looking at the male and female comparison, 74% to 26% compared to 80% to 20%, there is a difference, but is that difference strong enough for you to believe that it's not just because of random chance and sampling? Do you believe that the proportion is different in the way people look at their fingernails between men and women? So in this case, there's very little difference in the percentage of men and women looking at their fingernails in different ways. They're very similar proportions to each other. The samples for non-binary and prefer not to say are too small to draw any solid conclusions, so therefore you can't say that there's a difference. There's an association between gender and the way people look at their fingernails based on this particular study. However, I do have a large concern that the genders are not equally represented. So this causes a problem with carrying out statistical methods. If you have a very unbalanced study with a variable that you're trying to find an association with, this can lead to you saying there is no relationship when there is one, because you have to have a better design for your study.